Part B here of section 6, we're going to look at solving rational inequalities. Now this is going to be new, although it's similar to solving rational equations. We're going to do some very similar steps. So let's take a look at 37, and let me actually zoom in on this one first. Okay, the first thing you need to do is kind of look at your excluded value, or your critical value, sometimes we call it. And this is going to come into play when we're going to break things down on a number line for rational inequalities. But basically I have monomials down here of 3n and 5n, so my excluded value is 0. Okay, so if you think about doing what we just did, my common denominator, I've got 3n, 5n, and 3, so it would be 15n. So I would need to multiply this by 5, which means I'm going to multiply the top by 5. I would need to multiply this one by 3, so the top by 3. And this one I need to multiply by 5n, so I'm going to multiply by 5n. Now we've got the denominators all the same, so we can kind of just drop them off just like on the equations we did in the first part of this section. So I have 10 from 2 times 5 plus 4 times 3, which is 12, is less than or equal to 2 times 5n is 10n. So I'm going to go ahead and add these together. So 22 is less than or equal to 10n. I'm going to divide by 10. So I get 2.2 is less than or equal to n. What you need to do now is you need to look at two things. We need to look at the value we got here when we solve the inequality and the excluded value. And we need to think of it on the number line. So if I think of a number line, I've got 0 here, and I'll put 2.2 to the right of this. So these two things that we got when we solved here in the excluded value. What's going to happen with inequalities is, what's going to make it true is either going to be the things in between here, or it's going to be everything down here and here. So basically outside of those two things. Okay, and you need to do what's called a test value. I like to pick one that's in between. So I'm going to pick one that's in between. I'm going to try n is equal to 1. So 1 is in between 0 and 2.2. And what you do is you plug it into the original inequality. So if I go back to the original inequality, and I kind of wrote over it, but I'm going to rewrite it. It's 2 over 3n plus 4 over 5n is less than or equal to 2 over 3. So there was my original. I'm testing 1. So if I put a 1 in there, and I put a 1 in there, I really have 2/3, because 3 times 1 is 3, so that's going to be 3 on the bottom. This is 5 on the bottom, so this is really 4/5, is less than or equal to 2/3. If I combine these, okay, excuse me, I would find a common denominator of 15, so I would have to multiply by 5, multiply by 5, so it's 10. This one I'd multiply by 3, and that would be plus 12 over 15, which would really be 22 over 15. Well, is that less than or equal to 2/3? Well, 22 over 15 is not less, it's more than 1, so that is false, which basically means we tried something in between 0 and 2.2 right here, and it did not work. That means everything else in the middle here in between 0 and 2.2 is not going to work. So graphically, if you look at your solution, it would be pretty much 0 and below, and it's going to be 2.2 and above, and you've got to include both parts to that graph when it doesn't work in between. So how do you write your solution? We've got two parts. we're going to say n is less than or equal to 0. That describes kind of 0 and below. Or n is greater than or equal to 2.2. So that one's working kind of in opposite directions. So it's written as an OR statement.